This video is about the ProHub project. ProHub stands for Protecting Oral Histories Using Blockchain. The recording was done on the 15th of July 2022. The project has received funding from the European Commission's Connecting Europe Facility Program, CEF. We give an overview about the concept, principles, and main use case of ProHub. We then explain who the stakeholder is and which collections we use. We introduce an eArchiving use case for packaging collection data. We show how we manage and persist resource access information. And finally, we explain the concept of blockchain verifiable resource access metadata. The goal of ProHub is to demonstrate possible collaboration points and synergies between the eArchiving and European Blockchain Service Infrastructure building blocks. The eArchiving building block provides standards and tools for digital archiving, and the European Blockchain Service Infrastructure building block provides APIs to use the European blockchain services. The NIOD Institute for War, Holocaust and Genocide Studies, which is part of the Dutch Academy of Sciences, is the stakeholder of the project and provided several collections to test the concept of EBSI-based access mechanisms. The collections basically consist of personal reports and accounts of people who suffered during World War II. Technically, the eArchiving building block defines standards for packaging the collections. Each information package has so-called representations, which allow storing the collection items in different formats. Here we have a JPEG master representation on the left side and a searchable PDF representation on the right side, while the second is derived from the first one by applying optical character recognition to extract the full text from the image. The eArchiving standards allow organizing the data and defining processes for creating information packages which are submitted to the archive, the SIPs, information packages which are stored in the archive, the AIPs, and finally the information packages created for dissemination purposes, the DIPs. In this example, the DIP contains an aggregated searchable PDF file which bundles the individual searchable PDF pages available in the AIP. ProHub uses the eArch reference implementation eArchWeb to ingest and store information packages. An information package represents the intellectual entity and bundles the representations. In this case, below there is the representation with the searchable PDF pages and the images of the scanned pages. In the eArch reference implementation eArchWeb, it is possible to search for collection items. If the item is full text indexed, it is possible to find documents which contain a search term. In this example, we search for the location Bentheim, which returns one match. We can display the document of the search result, and the matches of the term Bentheim are highlighted in the document. However, the question is how resource access rights are managed. A couple of questions arise, such as: is the applicant allowed to access and use the resource? If yes, under which conditions? And is it allowed to apply search and retrieval tools to allow finding the resource? Does the resource maybe contain sensitive data? Is there a representation specifically created for dissemination purposes? Usually this kind of information is configured in the repository system using some proprietary format. But does this also work for the long term? We argue that there is need for a system-independent standards-based storage of resource access rights. This can be illustrated using the example of system migration. We start by defining a repository system A with some archival data on the left side. At some later point in time, the organization decides to choose a repository system B with the archival data and needs to do a system migration. There are two types of permissions in our use case. One is the permission to apply a specific category of tools, and the other one is the applicants or researchers which have been granted access rights. The point is that if access-related metadata and permissions are not persisted in a standardized way, they need to be redefined in the new system, which is a labor-intensive and a time-consuming process. Starting from the need to persist resource access metadata for the long term, we have defined a couple of requirements. First, It must be possible to define write statements on information package, representation, or file level. Second, it must be possible to define write statements related to the application of software agents. And third, it must be possible to define write statements regarding information applicants. According to the recommendations of the eArchiving building block, we use premise metadata for recording events and writes related to digital objects. We start by defining an object which stands for the intellectual entity, so for the information package as a whole. We can then introduce a second object, which represents the intellectual entity and which is the master image representation that we have shown before. And we define another object, which also represents the intellectual entity, and this one is the searchable PDF representation. Finally, we can express the fact that the second representation was derived from the first one. In summary, we can create objects for all levels, down to the file level, and thereby writes statements to all these levels. Regarding requirement 2, it is good to define or use a taxonomy of software agents, which allows grouping software agents. This way, we can assign write statements to a specific software, such as Tesseract OCR, to a group of, for example, optical character recognition software, to the group of information extraction tools in general, or at the highest level in this example, to the group of the tools for performing or enabling search and retrieval. We are then able to relate write statements to any of these levels in the software taxonomy. In this example, we take the most generic level of the tools performing or enabling search and retrieval, and define that this group is allowed to be applied to the representation created for dissemination purposes. This representation could contain anonymized content or where specific parts have been blacked out. If an internal policy states that applying the search and retrieval tools is allowed only if this is explicitly stated in the metadata, it can be demanded from the repository system provider to consider this metadata and enforce them. The third requirement is analog to the second one, with the only difference that the agent is a person or researcher requesting access to the resource. In this case, the license agreement is stored as part of the information package, and the event of the license agreement conclusion is recorded. The events of the license agreement conclusion consist of a sequence of steps which are recorded in premise metadata and registered in the blockchain in form of transactions. The steps are to register the dissemination object, create a text license document, then to assign the license to the dissemination representation in this case. In the next step, the applicant accepts the license and the provider approves the request. ProHub uses the European Blockchain Services Infrastructure EBSI, as we mentioned previously, and more concretely, the EBSI timestamp API. EBSI defines a series of use cases where the document traceability use case is the most relevant one for ProHub. With the help of EBSI, metadata events persisted in premise can be registered in the blockchain. This allows then validating premise events against the blockchain registry. As a conclusion, this way, authenticity of resource access metadata is guaranteed, and tampering of resource access metadata is prevented. This was our short introduction into the ProHub project. More information on the website prohub.ait.ac.at. Thank you for listening. Goodbye.